We don't come back again. H Radio School don't come back.
Hello everyone, I am Mr. D, your favorite radio school teacher. On February 1st, H Radio School will be coming back to teach you literacy, numeracy, and STEM subjects.
This is for out-of-school children.
We will teach primary topics on Mondays at 11 a.m., secondary topics on Tuesdays at 11 a.m., and we will have a repeat episode on Wednesdays.
Hope all of una don hear o. Make una tune in on Mondays, Tuesdays, and Wednesdays around 11 a.m. Parents, if your pikin no dey go school, make una try make dem go school for radio so your pikin fit learn. This is an ACE charity initiative powered by Grand Force Foundation.
This is a secondary school session for out-of-school children. Hello listeners, my name is Adesomi Temitayo and I welcome you to today's English class on ACE Radio School. In our last lesson, we learned that conjunctions are words that connect other words, phrases, or clauses together. We also studied the coordinating conjunctions, which has the acronym FANBOYS, meaning F is for, A is for and, N is for nor, B is for but, O is for or, Y for yet, and S for so. In today's lesson, we shall be learning another type of conjunction, which is the subordinating conjunction. Can someone say it? Subordinating conjunction. Very good. Subordinating is spelled S-U-B-O-R-D-I-N-A-T-I-N-G. Subordinating conjunctions. A subordinating conjunction is a word that connects an independent clause to a dependent clause. An independent clause can stand alone as a sentence. In other words, it does not need any additional information to operate as a sentence. The sentence, "The student failed the test," is an example of an independent clause. A dependent clause, on the other hand, adds extra information to the main clause. These clauses cannot stand by themselves, and their meaning is dependent on the independent clause. They are not complete sentences. For example, "Because she didn't study" is not a complete sentence. Examples of subordinating conjunctions: after. You will have your snacks after you finish today's task. The independent clause in this sentence is "you will have your snacks," and "you finish today's task" is the dependent clause. The word "after" is the conjunction linking these two clauses. 2. As long as. The chickens will keep going out as long as you don't lock the door. 3. Because. I passed my exams because I studied all night. Before. Read the instructions carefully before answering the question. Since. The police had to leave since they could not find any evidence. Although. I went swimming although it was cold. Unless. You cannot make good grades unless you study hard. Until. I will keep working hard until I become successful. Whenever. John begins to sneeze whenever he opens the window to get a breath of fresh air. Alright students, let's do a recap of what has been learned today. We learned that subordinating conjunctions are words or phrases that connect an independent clause to a dependent clause. Can someone remind us of some examples given? Yes. Before, very good. Since, although, one more. Whenever, awesome. Other conjunctions are as long as, because, unless, until, and after. Now, it's question time. I'd like you to listen attentively to the following questions and choose the option with the correct answer. Question number 1. Are you ready? Let's do this. Dash, the house was flooded. We spent all day cleaning up. A. While. B. After. C. Before. I take question 1 again. Dash, the house was flooded. We spent all day cleaning up. A. While. B. After. C. Before. Question 2. I don't want to go to the clinic. Dash, I hate the smell of drugs. A. Because. B. Since. C. Unless. I take question 2 again. I don't want to go to the clinic. Dash, I hate the smell of drugs. A. Because. B. Since. C. Unless. Question number 3. Dash, the principal came in. The students stood up to greet. A. After. B. As. C. As soon as. After question 3 again. Dash, the principal came in. The students stood up to greet. A. After. B. As. C. As soon as. Send your responses as a text message indicating your name, gender, state, and subject, that is English, to 070-363-03182. Take the number again, 070-363-03182. Alright, well done students for participating with your friends in today's English lesson. You can catch up on our past episodes on our YouTube channel called Ace Radio School. Don't forget to subscribe. Until I come your way again, it's Adesomi saying bye for now.
This is an ACE charity initiative powered by Grand Force Foundation.
This secondary school session is for out-of-school children. Hello listeners, my name is Mrs. Oluwashina Teniola and I welcome you to today's mathematics class on Ace Radio School. Today, I'll be teaching you factorization. I will explain how to factorize algebraic expressions. Get your pen and notebook and let's get ready to learn. Previously, I explained that factors are numbers that can divide through other numbers without a remainder. I'll take that again. Factors are numbers that can divide through other numbers without a remainder. For example, 6 divided by 2 equals 3. And 6 divided by 3 is 2. Therefore, 2 and 3 are factors of 6. Other factors of 6 are 1 and 6 because 6 divided by 6 equals 1. Also, 2 times 3 equals 6, which means that 1, 2, 3, and 6 are factors of 6. Let's consider this example. Factorize, open bracket, 3pq minus 2q, close bracket. Firstly, let's find the factors of 3pq. 3pq equals 3 times p times q. Therefore, the factors of 3pq will be 3, p, and q. Now, let's find the factors of 2p. 2p is 2 times p. So the factors of 2p are 2 and p. Great! Now, let's find what 3pq and 2q have in common. 3pq and 2q have Q in common. Fantastic. This means that I'll have to bring out Q from 3PQ so that what is left will be 3P. And I'll also have to bring out Q from 2Q so that what is left will be 2. Great. Therefore, open bracket 3PQ plus 2Q close bracket equals Q open bracket 3P plus 2 close bracket. Note that Q had to come out of the bracket since it is common with 3PQ and 2Q. Shall we consider another exciting example? Factorize open bracket Yusuf Abdullahi plus Ahmed Abdullahi plus Sekinat Abdullahi close brackets. Don't forget that we are looking out for what they all have in common. They all have the same surname, which is Abdullahi. Fantastic! I'll have to bring out the surname Abdullahi out of the bracket. Therefore, I'll have Abdullahi, open bracket, Yusuf plus Ahmed plus Sekinat, close bracket. Note that Abdullahi had to come out of the bracket since it is common with Yusuf, Ahmed and Sekinat. Wow, this is very exciting. Let's take more examples. Factorize, open bracket, 9AB minus 3BC, close bracket. Firstly, let's find the factors of 9AB. That will be 1, 3, 9, A and B. Don't forget that 3 times 3 equals 9. Now let's find the factors of 3BC. That is 3, B and C. Great. Now let's find what 9AB and 3BC have in common. 9AB and 3BC have 3 and B in common. Fantastic! This means that I'll have to bring out 3 and B from 9AB by dividing 9AB by 3B. This will be equal to 3A. Hence, what is left out of 9AB is 3A. I will also have to bring out 3 and B from 3BC by dividing 3BC by 3B. This will be equal to C. Hence, what is left out of 3BC is C. Great! Therefore, open bracket 9AB minus 3BC close bracket equals 3B open bracket 3A minus C close bracket. Note that 3B had to come out of the bracket since it is common with 9AB and 3BC. Quite easily done. Well done, listeners. We have come to the end of today's session. We learnt about how to factorize algebraic expressions. I would like you to try this as an assignment and send in your answers to this phone number 070-3630-3182. Type your name, age, gender, if you are a boy, type male, if you are a girl, type female, your class, and the state you currently live in. I hope you have done that. Now the questions. 1. Factorize, open bracket, 25PQ plus 5P, close bracket. 2. Factorize, open bracket, 8MN minus 4PM, close bracket. Okay, I'll be expecting your answers. You can catch up on past episodes on our YouTube channel called Ace Radio School. Don't forget to subscribe. We air primary episodes on Mondays, secondary episodes on Tuesdays, and repeat episodes on Wednesdays at 11 a.m. Until next time, it's bye for now.
We don't come back again. H Radio School don't come back.
Hello everyone, I am Mr. D, your favorite radio school teacher. On February 1st, H Radio School will be coming back to teach you literacy, numeracy, and STEM subjects.
This is for out-of-school children.
We will teach primary topics on Mondays at 11 a.m., secondary topics on Tuesdays at 11 a.m., and we will have a repeat episode on Wednesdays.
Hope all of una don hear o. Make una tune in on Mondays, Tuesdays, and Wednesdays around 11 a.m. Parents, if your pikin no dey go school, make una try make dem go school for radio so your pikin fit learn. This is an ACE charity initiative powered by Grand Force Foundation.
This secondary session is for out-of-school children. Hello listeners, my name is Ibrahim Mak, your ACE Radio School physics teacher. Welcome to today's physics class on ACE Radio School. Kindly get your book and pen ready to take notes. Today we will study the topic power further. In our previous class, we learned that power is the rate at which work is done. We also learned that work is the product of force and displacement, and the SI unit for work is joules, while the SI unit of power is the joules per second. We also learned that the SI unit, joules per second, has a special name known as the watt. The unit watt is named after a famous scientist called James Watt. James Watt is the inventor of the modern-day steam engine. James Watt realized that a strong horse could lift 150 pounds of load, which is approximately 68 kilograms, to a height of 220 feet or 67 meters in 1 minute. Mr. Watt called the power possessed by the strong horse as the horsepower. 1 horsepower has been accurately measured to be 746 watts. We will identify some devices and equipment around us whose powers are rated in horsepower. Examples of such devices are the electric generators, used for powering our homes and electrical devices in the absence of electricity. Air conditioning systems, used for cooling the interior of our homes, are rated in 1 horsepower, 2 horsepower or more. Other devices include electric blenders and food processors. The higher the power rating of an electrical device, the more energy it will consume during use. Therefore, it is a good practice to turn off electrical devices with high power ratings when not in use, to conserve energy and reduce electrical bill. Now let us solve an example. A farmer uses a strong horse to lift a mass of 150 kilograms up a distance of 5 meters. The horse pulls directly down on the rope. How long will this work take? At first glance, this question might look difficult, but trust me, it is rather easy. From our question, we were told that the load the horse is lifting is 150 kg and the displacement is 5 meters. What we want to find is the time taken to do the work. Let us start by writing down all the information we already have that can help us in solving this question. Firstly, we know that power is equal to work done divided by time taken. I mentioned earlier that a strong horse has a power of 746 watts. That means we know the value of power, but we don't know the value of work done. Remember, we can calculate work done as force multiplied by displacement. So what we have to do is calculate work done. But in our example, we were only given displacement, which is the 5 meters that the horse pulled the mass. However, notice we do not have force. Rather, what we know is the mass. Therefore, we need to calculate force so that we can use it to calculate our work done. The formula for calculating force is mass multiplied by acceleration due to gravity. That is, F is equal to ma, mass times acceleration due to gravity. In the example, mass is 150 kg. Since the horse is lifting the load upward, it means we can calculate the force needed to do this work by multiplying 150 kg by 10 meters per second squared, which is equal to 1,500 Newton. The 10 meters per second squared is the value of acceleration due to gravity. We use acceleration due to gravity whenever a body is being lifted upwards against gravity. And in our example, the horse is lifting the load upwards. Okay, now we have our force as 1,500 Newton. We can calculate work done. Hence, work done is equal to force multiplied by displacement, which is equal to 1,500 Newton multiplied by 5 meters, which is equal to 7,500 joules. Let us summarize what we know so far. We know that the power of a strong horse is equal to 746 watts and that the work done is equal to 7,500 joules. We are required to calculate how long the work will take. That is the time. From the formula, power is equal to work done divided by time. If we make time the subject of the formula, we get time taken is equal to work done divided by power. Substituting our values into the formula results in time taken is equal to 7,500 joules divided by 746 watts, which is equal to 10.05 seconds. With this, we have come to the end of today's class. But before we go, I'll give you some assignments. Kindly send your answers as a text message containing your name, your gender. If you are a boy, type male. A girl, type female. Your class, the subject, that is physics, and state where you currently live. To 07036303182. The questions are as follows. Question number 1. 1 horsepower is equivalent to how many watts? A. 446. B. 777. C. 746 watts. Question number 2. A man uses 300 Newton of force to drag a box along the floor a distance of 2 meters. If this takes 6 seconds, what power has he used? A man uses 300 Newton of force to drag a box along the floor a distance of 2 meters. If this takes 6 seconds, what power has he used? Give your answer in both watts and horsepower. Send your answers to 07036303182. I believe we had fun learning today. Till I come your way again on H Radio School, use your power to change the world positive.
This is an ACE charity initiative powered by Grand Force Foundation.